So today our learning intention, we will use this. We were talking about the difference between vector quantities and scalar quantities. Today we will look in more detail what is actually vector and how to deal with them. So today we learn about vectors. Now, first of all, vector is a directed line segment. A line segment that has direction. So it has length and direction. And if we denote, let's say, this vector with letter A with arrow at the top, and we can do some mathematical operations with the vectors. Who will be doing specialist mathematics will learn more operations with the vectors. We will look only two. We're not looking into the multiplication of the two vectors. And there are actually two types of multiplication. There's no division, but there are two types of multiplication: scalar multiplication, the dot product, and cross product. But that's not part of what we will be doing. We will look only into the, first of all, addition, subtraction. So if we add vector A, if vector C equals sum of vector A plus vector B. If this is vector A and this is vector B, the sum, we connect beginning of the vector A with the end of the vector B. That will be sum of this vector. So let's say this is points A, B, C. If you walk from point A to point B, and then from point B to point C, effectively your displacement is from A to C. That's what does it mean, addition of the vectors. So one vector that replaces your total movement. Now, let's consider the next situation. Let's say you walk 12 meters north, and then you turn at the right end and you walk 5 meters east. What is your total displacement? The displacement will be the sum of these two vectors. So that will be vector, this vector will be resultant vector. To find it, because this is a right angle, how we will find the distance, that's A, B, C, how we will find length of the vector AC? Using Pythagoras. So we will get square root. So let's say that vector C and the length will be equal square root of 5 squared plus 12 squared, and that one of the Pythagorean triples. What that you should know was 13 equals 13. 5, 12, 13, one of the Pythagorean. So it is displacement 13 meters. But is it completely described the displacement? When I say displacement 13 meters.
Can you have to say the direction?
Must, completely must. And how we find direction? You need to find this angle. How we find this angle? Using the basic trigonometry, SOHCAHTOA. So this angle will be equal 10 negative 1 or 5 over 12. That's how we can find the angle, because tangent is opposite over adjacent. So angle will be inverse 10, 10 negative 1 or 5 divided by 12. And I use your calculators. It will be something like, I estimate it as probably something like 23 degrees.
How would you calculate that? 22.6.
That's all.
Very nice.
Huh?
I'm ready.
23 degrees.
How?
Approximately
Mr.
20.
Vic, how did you know?
Hmm?
How did you know? You just looked at it
I
and
calculated.
how? How do you calculate tan negative 1 camera?
Okay. Now, that's how we add vectors. How we subtract vectors. If you want to subtract vector, let's say we have vector A, and we have vector B. And we want to find vector C, which is equal B minus C. That we, B minus A, and that is the same as B plus negative A. What is negative A? If we change direction of the vector to come to the same length, but just change length to open the direction to opposite. So that will be negative A. This will be negative A. Same length, opposite direction.
But for the first example, would the final answer be 13 units?
13 meters at 23 degrees from the vertical, or from north. Depends how that is described. No, that's this one.
No.
This one, if this is vector A, that will be vector negative A. And again, these two vectors B plus negative A, the resultant vector will be this. The resultant vector will be this vector. This will be vector C. As a difference between them.
What is negative A? What?
If this is vector A, this vector, same length, just opposite direction, is negative A. Now, so let's consider the question,
I don't know how C equals to B minus A.
because C equals vector B minus vector A. Minus A means same as plus negative A. Plus minus is minus. So we replace, and we have minus A plus B, because it doesn't matter if you have A plus B or B plus A, it's the same thing. So B plus negative A is the same as negative A plus B. Negative A plus B. So if you vector connected, this is the beginning of A to the end of B. Yes.
But how did you know C equals B minus A? How did you know that C equals B minus A?
This question asks find vector C that is B minus
Oh, so
vector
that's
A.
an example.
Yeah, wait. How would it be B minus A? Because I didn't know that.
Yes.
Like how? I don't get how C is B minus A. What? How do you know that? C is not C.
C is B minus A. That's what we need to find. Now, A minus A is the same.
Instead of going like up, he's just going the other way because he's still trying to find and like the
Negative A is this way.
Yeah, like he's just going like instead so like
Negative A plus B is the same as going this
So
way.
it goes like up and then to the right, so you have that like the 12 is up and then right. So you do that plus that. 12 times 5.
So, which part you don't understand? Do you
Like
understand
for
that?
example, in this one,
Just
C
thinking.
is 13. 13 is not 12 plus 5. So
But then we're finding length of these. We're finding using Pythagoras.
yeah. So then
We're not finding the length of the this, there is no right angle. We're finding Pythagoras here. I just show you that what it will be, but we're not calculating it. I even didn't give any length.
It's Python, right?
There is no even any length. We just find geometrically, draw what is the difference of those ends.
I think it's because like it's like A and B similar size. Like if you minus each other, wouldn't C be 0 or like very small?
Sorry?
If A and B are similar sizes,
But if they move along the same line, the result never will be zero.
End point here.
Let's consider now next example. In physics, we predominantly not adding vectors like this. We're using resolution of the vector. First, let's consider the next example. Let's learn what is the resolution of the vector in the x. Let's say we have this is the x-axis, and we have a vector A with a length, vector A, and its length is, let's say, 20, and this angle, let's say, 60 degrees. And this angle, let's say, 60 degrees. A resolution of the vector A into the x-axis, we draw the perpendicular from the end of the vector to the axis. This is perpendicular line. And that will be, this vector will be AX. Resolution of the vector A into the x-axis. That will be resolution of the vector A into the x-axis. Will be component of the A along x-axis. And that's what we will be finding predominantly in the physics, using resolution of the vector. What will be AX equal? What the length of AX equal? Equal 20 hypotenuse times cos 60. Cos 60 is 1/2, so it will be equals 10. And we don't need to specify direction, it's already done. It's in the x-axis. So AX will be equals 10. Cos 60 is 1/2.
That would be useful.
No. Let's consider one more example. If we have we have two vectors. We have so y-axis, x-axis, and we have vector A, one vector with a length of let's say 5, and this angle will be 30 degrees. And we have this vector with a length, let's say 4, and this angle will be 60 degrees. Let's find the sum of those vectors. To do this in physics, we find the resolution of the both vectors. So this is vector A, this is vector B.
Can't you just find the angle in the middle and then it's like if you have
In this case, it's pretty easy because what will be the end will be 90 degrees. But if it's not that easy, then it will be not everyone learn about the sine rule, cosine rule. I'm not sure it has ever. Who did last year you probably learn about sine cosine rule, but not all. So we're not using that. And I just make it more simple, but if it will be different angles, you cannot use like Pythagoras and this sort of thing here.
Yeah.
How we finding the resolution of the vector? So this will be AX, resolution of A into the x-axis. This will be BX. Does that make sense that this is AX? There is a component of A along X, this is a component of B along X. Does that make sense? Just draw perpendicular. Let's calculate them and find the sum. So CX, C is the result of addition, will be 5 times cos 30 degrees minus 4 times cos 60 degrees. Does it make sense why it's minus? In which direction is vector b? In the negative direction. This is in positive, we take it with the plus. This is into the negative direction, why you take it with the minus? So this one will be approximately 25. Will be 4, this will be about 4.3 approximately. Can you check with the calculator?
Is it cos 30 cos 6? Oh, it's cos 6.
It's roughly.
Yes.
Actually, supposed to
So 4.3. Can you please check with the calculator that it's 4.3?
2.3.
5 times cos 30? 5 times cos 30?
Yes.
2.3.
No.
No, it cannot be 2 points.
Yeah,
If
Huh? 4.3.
2.3.
You have in radians,
It's
probably.
root 3
No, it's
over
a degree.
Huh?
Your battery's
Yeah, it's in degrees.
What do you have? 5 times? Huh?
5 times cos 30 minus 4 times.
Not minus, I say just 5 cos 30.
Oh.
Yeah, 5 times cos 30.
30 is 4.3, 4 cos 60 is 2, and the final answer will be 2.3.
Yeah, that's what I said, 2.3.
Final answer.
Oh, I know.
Okay, makes sense? Does that make sense how we did it?
Yes.
Yes.
So when we're finding like the sum of vectors, it's just the one of vectors.
But that's alone. Now we need to do same for y-axis. And the resolution of A into the y-axis will be this. That will be AY, this will be BY.
You do the same thing.
And we do the same thing, just ends will be different. So we will have resolution of vector A into y-axis will be 5 times what?
5 times
60.
Sine 30. Because we now finding the opposite. 5 sine 30 plus
Which is a half.
plus 4 sine 60.
Hold on, you memorized the table.
Why is it plus if they're both going in opposite?
They both directed up here in y direction, they both in the positive direction.
So now it's just
In
one
x direction, one was in the positive, one in the negative. In y, they both in the positive. So we plus, yes.
But isn't the sign of every wants to be exactly one? I don't know.
No, we have now, we're finding this,
Yeah.
which equal this,
Yes.
right? And this is the opposite, so we hypotenuse times sine 30. For x-axis it was cos, for y it will be sine. For vertical it will be sine. It's opposite. So that's equal 5 times sine 30 will be 2.5. 4 times
5.96.
Yeah,
It's
that's
not
fine.
It is the same. It's like
5.96. So this is 2.46.
it's actually.
So that will be C Y. Does it make sense? Yes.
be 4 sine 30 and 5 sine 30.
Yeah, that's what I was thinking.
5 sine 30 because that is a resolution of vector 5 into the y-axis. That resolution, this equal this. What this side equals
Which one?
from SOHCAHTOA.
What do you think it's telling?
This is the opposite. Hypotenuse 5, this is the opposite side.
What?
How we find an opposite? Hypotenuse times sine. And this is opposite in this, so hypotenuse 4 times sine 60.
Mr. Bear, which one is say what?
Sorry?
Which one is say what?
Oh, look.
Which one is say what?
This is CY.
No, but where on the...
It's
on
the B, it's BY.
It's a sum of AY plus BY.
Oh, I thought you were finding the line horizontally.
We have found,
Yes.
Isn't that just say x then? IY plus y1. Which one say?
we have found that CX is an addition of the x components of vector A and vector B. So it's resultant vector in x, the resultant component in x direction. y direction, ay plus by will be resultant component into the y direction. So we have found vectors, no, we cannot found vector C. We have found only its x and y components.
Is vector C like the total man?
So we found a vector C. We have 2.3 is x component, and we have 5.96. 5.96 is y component. How we can find now total vector C?
Pythagoras.
Using Pythagoras. We need to find Pythagoras. So we'll have that C will be equal square root of 5.96 squared plus 2.3 squared. Dividing the diagonals.
How do you use that with Pythagoras?
This is the right angle. This is the rectangle.
What did you say?
This is 2.3, this 5.96, this 5.9.
It's 6.38839.
I was close.
So what is it equal?
6.39.
I was
So
close.
approximately 6.4.
But isn't
I
that
thought
the
that
target
was
for
something
Pythagoras?
Oh, that's the
Right?
This way,
Yeah.
does diagonals of the rectangle have different lengths or same length? If you have rectangle,
Same.
this diagonal and these diagonals, are they same or different?
Same.
The same.
Okay, so
Why I draw this line? Because what will be the sum of these two vectors? It will be that way, not that way.
yeah.
Oh,
Got you,
it's a
right.
positive.
So, what the last thing we need to find? Angle. Angle.
It's 6.39. Oh, you did it.
Find this angle theta, and that will be equal 10 negative 1 of 5.96 divided by 2.3, and that will be, I will estimate it something like probably, it is about,
Let him cook.
it will be something like 78 degrees.
17?
What you got?
What did you say?
78 degrees.
Minus 10.
Hmm? 68 degrees?
Yeah.
68.898.
Right? I think we calculated it wrong.
Okay, so can you repeat? 68 degrees?
68.898, sorry.
68 degrees.
Like it.
Now, does that make sense, the procedure?
Yes.
Of course you need to create. Where you will need to use it? Not much in kinematics, but you might need to find total displacement if you know that, let's say, rough box 20 meters to the west and then 10 meters south, what will be his displacement. But predominant where this thing, finding the resolution of the vectors, not necessarily doing Pythagoras, but finding ax and bx, ay, dy, this thing, when we look into the forces. Without this, it will be impossible to find the result when we have multiple force acting on object. Without this, it will be impossible to find the net force. So that's how we operate with the vectors. So we will do more practice. It will become more understandable, more easy with the practice. That's the new thing that I wanted to explain today. Now continue with the worksheet that you have started yesterday. Is question about vectors? Yeah, I will ask later.